Hello, and welcome to Big Data Technologies. I thought I would rejoin, uh, and actually spell technologies correct, um, rejoin and revisit Module 2. So Module 2, as you recall, deals with special handling of big data. So the basic idea here is to talk a bit about I/O, file I/O inside of big data environments, in particular inside of the Hadoop and HDFS environment. So by the end of the experience, you should be able to demonstrate file I/O within a big data environment. You should also be able to evaluate the architecture of Hive and justify applications for reading and writing to data in Parquet files. So why is Parquet a good thing? And then talk a bit about ORC or ORC. So jumping straight into the module overview. So Hive, Parquet, and ORC, what are they, or ORC? Hive, an SQL-like environment used in big data, generally or originally backed by ORC. So that was the format, and that's why we're even talking about it. Parquet came along afterwards. It's columnar in nature, very, very popular, and can also be used with almost any of the technologies. So why use Hive? Well, it's an easier way of doing big data processing. And putting it in context, it's kind of the same sort of thing as why Databricks with its SQL Spark sort of interface, Spark SQL, is very popular as well. It's because those with limited knowledge of a technology can utilize it in a very compelling and effective way. Sure, you might be able to get more efficiency by writing handwritten code, but most people, or a great deal of people in this domain, know SQL. Not so many know things like Scala, Java, and Python. So moving on to some other key terms, we talked about Hive. File formats, Parquet, ORC, talked about those a little bit. Types of database stores, columnar in nature, and so on. So let's go ahead and jump into these things. So what's Hive? It's kind of like a data warehouse, but data warehouse for Hadoop. Basic idea is that you have a way of querying using an SQL sort of language, and that SQL language gets converted into MapReduce jobs. So that makes it compelling, and that's why people use it. It's not meant for transactional processing, very much about reporting and batch sort of processing. So Parquet was inspired by Dremel, a query system. It was built by Cloudera and Twitter. It's optimized columnar data format, so it's very much about dealing with columns of data. And the reason that's compelling is sometimes you don't want to deal with an entire row inside of a data set. You want to deal with one or two columns. And in fact, you think about it, that's probably the more common case, is that you're only dealing with a subset of those columns at a given point. You can do some compression, and you can split the file into various ways, both rows and columns. It's used by Impala, Drill, Hive, Pig, Spark, and lots of other stuff. So it's a very commonly used pattern or commonly used format. The metadata is stored at the end of the file rather than the beginning, so that allows for a single pass whenever you're writing the file. So you don't have to go back up and insert some sort of header or something. You write it at the very end so that it's a single write through the file. It's good for wide data, so lots and lots of columns, and it does support the concept of schema evolution, which is that things change over time. You add new columns, you may remove columns, although that's less common than adding new ones, or you may kind of change the nature of a column over time as well. ORC, it's used to store data inside of Hive. It's a collection of rows in a single column-wise format. It allows access to a column of interest, skipping those that are not needed. And you also have this concept of a stripe, which is a way of improving performance. I'm going to pause right now and go start on what I hope to be the second part of this discussion. I'm going to see about provisioning an HD Insight cluster. So to get that started, I'm searching for HD Insight in the marketplace. I'm creating Azure HD Insight. I'm going to put that into a big data actually I'm going to create a new one and call it Hadoop Allen. And that's just so that I can later come back and delete the whole thing in an easier way. I'm going to call this Alan Hadoop, and it's checking to see if that's a unique name. Kind of improbable that it's not, but could be. So it is a valid name. I'm going to select the cluster type, and I'm going to say it's Hadoop. Again, I'm going to leave the login as admin and give it a long, painful password so that I'm sure to mistype it. And just like I said. I'm going to leave the SSH user as SSH user and use the same password for both the cluster and the SSH login. I strongly recommend you do the same thing. Moving on to storage, I'm going to pick an existing storage account, and I'm going to give this a name that is much easier if I ever want to come back in and do it again. And I'm going to call it Alan Hadoop. That's the container that's going to be created inside of this storage account. You'll want to make those two things line up if you come back and create a cluster a second time. And with this, I think that's about all I have to do, other than I've got to configure this bit. And this is where my notes come in real handy. Make a mental note, I'm on slide 8. I'm going to skip to 10. And go ahead and start this. So I want a E2 for the head and an A2M for the workers. And I probably want just 2 of those. Or if I can get by with 1, I'll do 1, because you're not going to be doing a lot of workload here. This is an A2, and you don't pay for that one. And you probably want to drop that down to an E2. And these SKUs that we're dealing with, I think it was an E2v3, E2v3. It's a class of processor, basically. And I'm trying to go for cheap, right? Because what we're doing here is not terribly complex. I'm not going to save that password. I'm going to review and create. And go ahead and kick off the creation, because it does take quite a while. Even then, I'll probably end up needing to pause this recording so that I can resume without it being, 15 minutes of me doing a song and dance. So at this point, it's telling me that it's going to cost 51 cents an hour when this thing exists. Notice that it's existing, not running. So do delete them when you're done. And I'm going to go ahead and say create. And then now I'll shift back and talk while it's starting the process. And it does take quite some time. So while it's doing that, we'll go back here to ORC. So ORC, the only reason I think we talk about it much is because it was the data type that was originally used with Hive. It's not really terribly relevant today. Parquet has kind of taken over. And primarily because of the ability to partition it nicely. You can do the same thing with this using this concept of a stripe, which is a series of rows, around 10,000 of them, to improve performance. There's a magic size in big data. You don't want your files too big, and you don't want them too small. Too big and you can't get them into memory. Too small and you're spending all your time doing I/O, and you're potentially going to kill your part of your cluster. So you basically want it a reasonable sized file, and that's going to kind of depend upon the particular environment. But the idea is that bigger is usually better to a certain point. And you can read those stripes independently. Just talked a little bit about HD Insight, and I'll go ahead and add a little more kind of color to it. HD Insight is nothing more than a variation or a distribution of Hadoop that Microsoft has adopted and is exposed as a managed service. It is managed in the cloud. You do incur charges as long as it exists, so that is part of the downside. You can access all kinds of storage, data lake, blob storage, whatever, and it is this is the basic architecture that you'll see. Is there's head nodes and worker nodes, and there are a few other ones that we have to provision as well, those zookeeper nodes. You don't pay for those, but apparently they're necessary. So I'm not 100% sure why that is, but it's something to do with the way that it's organized. Talking about Deliverable 2, we'll go ahead and go over that while HD Insight's doing its thing. Your competency that you're trying to show is to be able to demonstrate file I/O with a big data environment within a big data environment. You'll be graded on using the rubrics that is located inside of the course room. Always review those rubrics because I grade them, I buy them explicitly if you haven't seen that. Imagine that you're working at a big data corporation. You're a data clearinghouse organization that provides data services to thousands of customers. You need to showcase your ability to process big data, so that's what this is all about. So you're going to basically create an application that reads and writes data in a big data environment. To do this, you're going to basically create as small as you can Hadoop cluster inside of HD Insight. You can't do a single node, as we've seen. You've got to have at very least a couple of drivers and a worker. But you get the intent that it's to be as small as can be created. And then the link and the resources instructions don't necessarily work. I've tried that because of the restrictions on the number of CPUs and types of CPUs that are available. You're going to extract the big data or the background checks data file and import it into Hadoop. If possible, which you can't do this, you can't use your local hard drive as a data node. So don't worry about that. And then you're going to basically import the data in, and then you're going to submit a document describes your development process, including screenshots to the clarity of your work. So basically show me what you did, including those things that don't necessarily work. Here's some resources that might come in handy. The rubric, as always, shoot for the green. And pretty much that's about a thorough and detailed document is the kind of the differentiation there. Can be presented to the potential clients and so on, free of errors and uses professional tone. And so just do a great job and it'll be fine. An application that reads and writes data and screenshots of doing so. And with that, that's the end of the presentation. And now I'll skip back over here, and I will probably pause this for a bit until it finishes provisioning of HD Insight, and then I'll pick back up before I do something interesting. So I will return. All right, the deployment finally completed, so now we can go to our resource. Running a little bit slow today. And so the URL for HD Insight. And I believe that was I'm not going to save that because this won't stick around. Okay. While it's doing that, I'll go ahead and open up a command prompt. And go to connect. So SSH and cluster login. Copy that and paste it over here. And yes, we want to connect to the server even though we've never done so before. it's doing that, we can take a look. This is basically a dashboard for our cluster. And I'm looking to see if there happens to be some handy things here, and I don't think there are, that let us do things like upload files, and so we'll probably need to do that a slightly different way. Yeah, this is basically about the status of the cluster. So for some reason it's taking quite a while to connect to via SSH. So while it's doing that, I'll go ahead and take a look here. This is the Storage Explorer. So what I did was go into my storage account and used Storage Explorer over here on the left side. And what it does is there's an install Storage Explorer you saw across the top. This is a way of navigating the contents of your storage account in a kind of UI-driven way. And what I'm doing is I want to go take a look and see what's inside of this Allen Hadoop blob container, which is where whenever we did our configuration, we told it this was the storage that it should use. Blob containers, a blob is literally a file that emulates a file system through the way that the name is constructed. So it looks like there are directories here, but there aren't really, because these are basically just the files that exist inside of the what looks like a folder is what makes it exist, and so there's a file that has a name that has got all this stuff in it. So what I was taking a look at is to see, probably I want to go look at home. I'm not seeing a home, because what I'm trying to do is find an easy way to upload our data. So I'll probably go take a look here in the example folder, even though that's not exactly what this is meant for. This will probably work nicely. So what I'll do is inside of this example folder is upload a file as soon as I remember how you do it. Oh yeah, you click the upload button. And so I click on upload, and what that's going to do is place it into this example folder. I navigate to the file of interest. In this case, I'll go ahead and do the Deliverable 2 data file, or a variation of it. And this is, I actually pulled this off of the original website where it came from, off of GitHub. And so to make that a little less copy or typing later on, I just creating a copy of it, and I'm going to rename it. This is one of those little known things you can do inside of a dialog box inside of Windows. I actually created a copy and go back up a little. And of course, Explorer's not in a good mood today. Okay, there it goes. Back into data. And I'm going to change that name to just background. And then I'm going to select it. So I'm going to click on open. And then the idea here is to upload this into this folder so that we can use it potentially from inside of Hadoop. And this is just an alternate way of handling getting the file into Hadoop. So for some reason that timed out. I'm going to try it again. And you can see we've got now a background folder in the background here that is an Excel document, CSV document. And then wanting to know the password again. And this should connect rather quickly, so I'm not real sure why it wasn't, unless it's because I've got some other things going on. And as far as the assignment goes, if you get close and explain what you've learned through the experience, what you did to upload, if you do something like run word count, for example, that technically is reading and writing data to HDFS, that'll be perfectly fine. So there's a certain amount of flexibility here, especially given that this level of interaction with Hadoop clusters can be sometimes spotty, as you can see right now. Looking at this could be a product of me having it on the lowest hardware I could find, but I don't think so, because all I'm trying to do is log on, right? And I'm not actually really logging on to Hadoop at this point. I'm just attaching to the virtual machine that's running Hadoop. So could be that it needs time to kind of get stabilized, but I don't think it's terribly overloaded at this point. So it's probably something else going on. And because if you look at the cluster load is non-existent, right? And CPU usage isn't really that high either. So definitely something going on, but I don't think it's us. So again, on this deliverable 2, there are lots of different ways that you can go at it. You can install Hadoop via a virtual machine image locally. You could install Hadoop inside of Windows Subsystem for Linux 2 locally, which is what I demoed last week successfully, finally. Or you could create a virtual machine in Azure, and from one of, I believe I talked about that early on, that is using one of the pre-existing images that way. That's another solution. Or you can go the HD Insight route, which frankly has been a little problematic, right? So really up to you. Any one of those is good. And if we take a quick look at the rubric, give me a moment to find the right screen. And moving into course project. Maybe the problem is my network. Deliverable 2. Try this one more time. So while we're doing that, look at the rubric. So let's walk our way through this, right? A thorough and detailed document has been developed that can presented to potential clients that discuss the applications that have been created and how it can be used to read and write data in a big data environment, free of errors and so on, professional tone. And then, so that's pretty much creating a reasonable document that talks about how it can be used. And then an application has been created that reads and writes data into a big data distributed computing environment. Screenshots provided that shows that the application, as far as I'm concerned, that can definitely be word count. Word count does both read from and write to HDFS. So word count is fine. Asking you to create a Java program at this level is a bit extreme, especially given Hadoop is less relevant than it once was. So get close on this, give me something to work with, and we can get through it. But with that, we'll go ahead and shift back and take a look here. And it's obviously not going to let me in. And so if I have challenges doing it, it's a unreasonable thing for me to expect you to get into it as well. Do a quick see if there's anything that I can see right away. But if for some reason you're able to get it up and running and can actually get onto your SSH, if you use this approach that I showed you here, you can actually drop something into what would be the slash, the wrong slash from a DOS perspective. So the slash that we don't use. So the one that's by your left of your shift key, most likely on the same control as the question mark. But so when you come in and take a look at the root of this environment, it'll be /example is where the file will be, and background.csv would be in there after you've uploaded it to that location. You could do that pretty much anywhere. There should be a home directory, which I'm not seeing for some reason, so perhaps they're doing something slightly different. I don't see, and maybe it's because we're logging in as admin. None of these are the home. These are home for the various installed programs, not so much for the administrative user. You could also drop things into temp, especially given that you're going to do this very quickly, do your processing and then pretty much get out of it. Temp is the equivalent of a temporary location like we have in Windows. If you go %temp% inside of Windows, you'll go to a temporary location that's purged after elements are used. Same sort of concept here. And it's refusing to let me in. So I'll go ahead and wrap this up. I'll go ahead and delete my cluster, as clearly isn't going to happen on this go, and then we can connect again later to see how you're progressing. If there's anything I can do to help, let me know. That's what I'm here for. Stay safe, and we'll talk again on Wednesday.